see the slides?
Yes, ma'am.
Okay. So we will come to the part. This is the air quality in India near Diwali, as I showed you yesterday. But I will start from where we had left yesterday, right? So, what is air quality index? As you all know, this is a tool that would help in disseminating air quality status to people in easy to understand terms and thereby ensuring larger public awareness and participation. So these are the instruments which are used for measuring, monitoring the air quality, and the air quality is index. The National Air Quality Index in India was launched in 17 September 2014 in New Delhi. As I told you yesterday also about this, and there is web-based system for air quality monitoring, right? So the proposed air quality categories and range. There is a elegant color scheme as shown below. 0 to 50, green color, it is good. 51 to 100, light green, it is satisfactory. Moderately populated is yellow in color, and the little dark yellow shows the poor quality, that is from 201 to 300 air quality. Very poor, 301 to 400, and then comes the severe from 400 to 500. So this is the color category of air quality number. The impacts, as I told you, good has minimal impact. The satisfactory shows minor breathing discomforts to sensitive people, moderate breathing discomfort to people with lung disease such as asthma, and discomfort to people with heart disease, children, and older adults. So, elderly people have more health risk. Poor shows that breathing discomfort is observed to people on prolonged exposure and discomfort to people with heart disease with short exposure too. And very poor significance the respiratory illness to people on prolonged exposure. Effect may be more pronounced in people with lung and heart diseases. So this is observed. And severe, respiratory effects even on healthy people is affected by this type of air quality, and serious health impacts on people with lung and heart diseases. So this is what the elegant color scheme signifies. And now if you see that there are these parameters, that is particulate matter, the NO2, ozone, CO, SO2, ammonia, and lead. These are the different uh, pollutants which are selected, and generally these are the most affecting, and these are monitored by the different research agencies and government air quality monitoring stations, and the values are given. This is, the air quality index, and the range is for PM 2.5. If I say 24 hourly, it is covered, and the range good is 0 to 30. It should be only 0 to 30, the concentration of this pollutant, that is particulate matter 2.5, and it is very severe if the concentration is above 250. So we see that this value which is given in this column, this is linear function of the concentration. For example, the subindex for PM 2.5 will be 51 at concentration what? 31 microgram per meter cube. If the concentration of PM 2.5 is 31 microgram per meter cube, then what will be the air quality index? It will be satisfactory, and it will come in the range of what? Satisfactory zone. Now, if it is what? 75, so at what concentration of PM 2.5? That is 45. 61, the air quality will be 101, and everything starts deteriorating. So the worst subindex, or you can say the maximum of all parameters, determines the overall air quality index. This I will explain you in the next slide too. So if you see the construction of AQI, it is based on the measured ambient air concentrations, corresponding standards, and likely health impact, known as health breakpoints. A subindex is calculated for each of the pollutants. A subindex is a linear function of concentration. For example, the subindex for PM 2.5 will be 51 at concentration what? 31 microgram per meter cube. 100 at concentration 60 microgram per meter cube, and 75 at concentration 45 microgram per meter cube. How you can calculate? I will give you two examples to explain this properly. So if you have to calculate the subindex, how it is calculated? For example, if you are taking PM 2.5 at concentration of 45 microgram per meter cube. 45 means in this scale. 45 means in this scale it will come in this range, that is 31 to 60. It will be satisfactory, and that is why I have taken this from this table. So it is in this range, that is satisfactory zone 31 to 60. Now this is the formula for this calculation, that is you take 50. 50 means you have the upper limit of the previous air quality category to which the pollutant's current reading would have fallen. Because this has fallen in this range, this has fallen in this range. So the air quality index, the upper value you will take, and this is 50. So here comes 50. Then you will add this to the current reading. Current reading we have to calculate for concentration 45 microgram per meter cube minus 30. 30 is the upper limit of the previous reading, right? Previous reading category of the pollutant. So this is 30. From here you have got 30. Now 50, this will be multiplied by 50 divided by 30. That means now this is the width interval of AQI. Width interval is what? 0 to 50, it is 50. And the width interval of the current reading, that is how much? That is just 31 to 60, it is 30. So if you solve it, this value comes out to be 75. BODMAS, and you will calculate the value, it comes out to be 75. Similarly, for PM 2.5 reading coming at concentration 150, this falls in very poor category range. It is marked with red color. So what you do is you first put this value, that is 300. This is in this range. So upper air quality index, upper value you will take. So this is 300 plus 150. This is the concentration range for which we are calculating the subindex, and minus 120. This is the upper value in this category, right? For PM 2.5, this is 120 into 100. So what is the difference between this? This is 201 to 300. This is 100, and the difference in this is 130. So if you calculate this, it comes out to be 323, right? So this is how you calculate the subindex. And these are the national ambient air quality standards. Time weighted average, that is for those, it is annual, it is written annual, right, for 24 hours. And in some cases, for example, ozone, it is 8 hours, 1 hour, right? Even for carbon monoxide, it is 8 hours and 1 hour. So it is mentioned, the time weight category. Now, this is the concentration in ambient air. It should be in industrial, residential, rural, and other areas. For example, I will just take up one and explain you. This should be 40 and 60, not more than this at any cost. For ecological sensitive areas notified for central government, if it exceeds this, it will create a havoc, and there will be a densely air pollutant in the atmosphere, and the air quality index will what? Increase to a very high level. And these are for the next, your benzene, your arsenic, nickel, and all. So this is the table which is showing the values for different pollutants. Now, international comparison, if we see, WHO also measures air quality across major cities of the globe. The WHO data contains results of ambient outdoor air pollution monitoring from almost 1,600 cities in 91 countries. Air quality is represented by annual mean concentration of particulate matter, generally PM 10 and PM 2.5, that is particles smaller than 10 micron or 2.5 micron. This is what PM 10 and PM 2.5 is known as. Until Diwali, this will be shown on your television screens, your mobiles, wherever you go, it will be shown, because the pollution level has increased tremendously, and it will keep on increasing till Diwali. Even post Diwali, you will see a very bad air quality index, and slowly it slows down, right? So we have to take all the precautions so that the air quality doesn't rise. For that, I will come to the next slides. And the world average PM10 level by region range from 26 to 208 micrograms per meter cube, with the world's average of 71 microgram per meter cube. Now, AQI India launches a mobile app to help users track air pollution levels. These apps are launched so that the general public, not only the science people, but also non-science people, can understand what is air quality index and how it is going to affect our health. So it is very important that these values should reach the mass. Air Quality India, as you know, has launched a new mobile app that will enable users to search and explore the location of their choice and check real-time values of the air quality index. and PM 2.5 separately. Based on the data of a specific location, the app will also provide personalized health recommendation. This is more important. So nowadays, government is focusing more on the health recommendations of this AQI. AQI India, with its intelligent algorithms and high precision pollution detection sensors, captures every minuscule of air particle and publishes highly accurate readings. So this is how, this is the app showing yesterday's, I think so, this is of Rohini Sector 2, 426. So how you can determine the air quality? I told you we have the air quality index, right? And the air quality index guides policymakers to take broad decisions and encourages citizens to participate in air quality management. So that is why it is very important. Now, scientifically and in your studies, if you see how the development of aggregate air quality index is noted. So generally, what is there? This is from the environmental measurements, which we get the values of X1, X2 and Xn, whatever pollutants, right? So we have nowadays 12 pollutants. Most important is particulate matter 2.5. So we take the concentration of this and then we find out the sub-index, that is I1, I2, In, similarly so on, whatever we have, right? So we have these values and sub-index are function of this concentration of the pollutants. Then we do the aggregation. The aggregate index I is equal to what? The aggregation of the sub-indexes. So these are how the step 1 and step 2 are accomplished to get the air quality index. Further, let me tell you the sub-indices to air quality index. So this is the individual pollutant, SO2, ozone, PM 2.4, right? And we have CO, SPM, right? So we from this will calculate the sub-index value, and the maximum of the sub-index value will give you the air quality index, and this is internationally accepted scheme. So this is accepted internationally. Just for example, I don't want to put a terror in your mind that the air quality index in MDU is very high, but to be very clear, this is just a value which I have put, and there is, automatic calculator on your net also. You can see if you put the value of these, if you have some measured values on the gate, if you see the values of this and you try to put this in the calculator, what you can calculate the sub-index and check the air quality. Immediately it will give you the air quality. Suppose I had feeded these values for MDU campus. Yesterday I had filled manually. These are just to show you that these are the values for PM 2.5. I just took 45 microgram per meter cube, right? So this is how we have put these values and we get the sub-indexes, this, and the air quality index comes out to be 75. I calculated this and showed you how we can calculate the air quality index if the concentration of PM 2.5 is 45 microgram per meter cube. So now you see that there are different sub-indexes, but you will only say the air quality will match this with what? You will say the air quality index is 75. So the maximum, this slide shows that we get the value of sub-indexes, but the maximum sub-index that will represent the air quality index, not the lower one. So just the maximum value predicts the air quality index. It gives you the exact air quality index. So again, one more example I have taken. For example, you have for PM 2.5, air quality index is 125. The PM10 air quality index is 50. SO2 is 30, NOx is 50, and other pollutants are less than 125. Then the air quality index will be 125. That is, it is only determined by this PM 2.5 that is having the value 125. So it is determined only by the concentration of 2.5 because it is giving the highest value. Do you understand this now? Right, students? I'm not hearing anything from you. Yes? Can you hear me, students?
Yes, ma'am.
Okay. So could you understand this formula for air quality index?
Yes, ma'am.
Okay. Now, this slide shows the air quality index in Delhi. This is the map. This is from web page I have taken. This is in the air quality index at IG airport. This is yesterday's reading. I had put this value. I had just put the station here and the state, the city, and the station and calculated the value. This comes out to be 460. And then I tried it for Haryana state, Rohtak, MD University. Yesterday I calculated the value and it is very severe that the value is 441. It is showing the values for PM 2.5, NO2, SO2, CO, and ozone. So the average maximum for the PM 2.5 is 441. So the air quality index is 441. So understand how difficult it is just for us to breathe. It has just become a cocktail. The air has become a cocktail of toxic gases. So there are some health recommendations. Wear mask outdoors, run an air purifier, right? Close your windows to avoid dirty outdoor air, avoid outdoor exercise. So these are the recommendations which you get. So the particulate matter, though I have covered this, shortly I will tell you about this. Larger particles, that is PM10, right? Smaller inhalable particles penetrate into the lungs. They enter the thoracic region of the body and go deeper down when the PM level is 2.5. So smallest particles, right, may enter the bloodstream. Deposited particles may accumulate, react, and be cleared or absorbed. So this is how these particulate matter. I will emphasize on 2.5. Exposure to fine particulate matter can negatively impact the heart and lungs and can lead to health issues like asthma attacks, chronic bronchitis, and heart attacks. Exposure to PM 2.5 is also linked to increased emergency rooms visits and hospitalization. There are more hospitalization if we breathe outside nowadays due to respiratory and cardiovascular problems which will arise in this bad air quality. as well as there is increased risk of premature mortality. Children and those with pre-existing cardiovascular and respiratory diseases have greater sensitivity to these effects. It also has effects on environment. You all know the impacts on the environment can vary depending on chemical makeup of the air, right? But mostly PM can cause changes to soil and water chemistry. This can adversely impact organisms and vegetation. PM 2.5 can stain and damage stone and other materials, including culturally important objects such as statues and monuments. Taj Mahal, as shown in the pic, shows the effect. PM 2.5 also contributes to reduced visibility, which affect cities, airports, and wilderness areas and can negatively impact tourism and the economy, of course. So this is how it is affecting. Carbon monoxide is an important criteria pollutant which is ubiquitous in urban environment. CO production mostly occurs from sources having incomplete combustion. Due to its toxicity and appreciable mass in atmosphere, it should be considered as an important pollutant in air quality scheme. So the others are ozone, which I have dealt in detail, SO2, NO2. Now I will come to the measures to control air pollution. The Central Pollution Control Board, along with State Pollution Control Board, is conducting the national air monitoring programs. Various programs are being run, and this particular is covering 240 cities in the country with more than 342 monitoring stations. But more monitoring programs should be conducted and it should be reaching the masses. The air quality index should be notified to the general public. What measures should be taken to control air pollution? As you know, the government has taken several steps to control air pollution in New Delhi and in the NCR regions. These measures include promoting CNG-based transport as per auto fuel policy. Even Kejriwal has implemented odd-even formula in New Delhi. Even the strengthening of public transport is important. So this is the pic showing the effect of odd-even formula. See, the Delhi, the traffic is so dense. Odd-even, the traffic is less. Then spraying of water in trees is a very good solution. Road cleaning through vacuum cleaner is important these days. And if you just do it with the normal swipe, it may create more dust as shown in this figure. So spraying is also very important, and we can use vacuum cleaners to clean the roads and all. Temporary ban on construction activity should be there, and stopping operation of coal-based thermal power projects is also important in this situation when the air quality index has risen to more than 500 also at some places. So these two things are very important. They should be stopped temporarily. Even farmers should stop stubble burning. what you call is the burning of the rice straw and other paddy, etc. Right? So ban on all variety of crackers on fire and or the different fireworks on festivals. Dear students, today let us take a pledge. And I tell you, you all should pledge with me today, this Diwali, that we will not burst firecrackers and celebrate Green Diwali together for a wonderful atmosphere. I'm sure this will create good vibes in each household. So, dear students, use earthen diyas, right? Earthenwares, the diyas for Diwali. Don't use the plastic lights for home decoration, right? Shun the burning of firecrackers. Go for organic rangoli. Use natural colors and dyes like rice flour. You can use turmeric powder and petal and the leaves for making the rangoli on Diwali. So do make the rangolis and post it on the WhatsApp group. New technology that decomposes cropped stubble has been developed. Delhi government is set to start preparation of a biochemical solution, a new technology that decomposes crop stubble so that it doesn't need to be burned. The technology would prove to be a solution for the farmers who otherwise end up burning paddy stubble, causing fumes that add to the air pollution during winter. So this is the decomposer which has been used recently in Delhi by the Chief Minister of Delhi, Mr. Kejriwal. And it has been developed by Indian Agricultural Research Institute, Pusa, Delhi. So this decomposer has made a capsule which would be converted into a liquid solution and sprayed on fields with crop stubble. The solution, once sprayed on the fields, will decompose the stubble, which can be used by the farmers to treat the fields. And the nutrient value of the soil will also be increased. So it is benefiting two ways. So I would like to say that it is not right practice to blame the government for every problem. People's participation is very important to solve any problem. And if you see, the lockdown was a real gift to this air pollution problem. The first total lockdown was on 22nd March 2020 to stop the spread of COVID-19. Then it was extended for 21 days on 24th March 2020 in the first phase. During the total lockdown, most of the sources for poor air quality were stopped in India. You see the India Gate picture, it was so clear in lockdown. And now the upper one you see, this is having a very bad air quality index. And this is the river Ganga. Peak in lockdown. So Indian analysis using ground and satellite observations of air quality showed a pronounced decline in PM 2.5 and air quality index in Delhi, Mumbai, Hyderabad, Kolkata and Chennai. And everywhere globally. Also, a declining trend was observed in tropospheric NO2 concentration during the lockdown period in 2020 compared with the same period in the year 2019. 90. And this is the pic which I have taken of MDU campus in lockdown. Very clear picture. So during total lockdown period, the air quality was improved significantly, which provides an important information to cities administration. They should develop rules and regulation on how to improve air quality. So lockdown period really taught us that how we should behave, because there was no air traffic, there was the total lockdown. So we can take measures to improve. How to achieve air good air quality index. Government to ponder on how to strictly minimize vehicular and industrial pollution to improve air quality, which will help to sustain better public health in India. Further, the success of a nation to improve air quality depends upon the support of its citizens who are well informed about local and national air pollution problems and also about the progress of mitigation efforts. So, how to protect health when air quality index is poor? This is also very important, and I think so. I cannot end up without telling you avoid exercising or working outdoors for long periods of time. Choose less strenuous outdoor activities. Avoid exercising near busy roads. Postpone your outdoor recreational activities. Avoid sources of particles indoors also, like wood burning, stoves, fireplaces, and candles. So do yoga at home. I urge all of you to join hands in ensuring better air quality index for ourselves and for our future generations. Thank you. This is all for the day.